Good morning, everyone. I am Pandit Prasad, Principal Product Manager at Amazon RDS. Joining me today is Vijay Karmaji, our Senior Database Specialist. Today, we are going to talk about the new multi-AZ deployment option on Amazon RDS. This is the agenda for the day. We will start with an overview of the multi-AZ feature. We'll talk about the two deployment options that we have on Amazon RDS multi-AZ. We will show you a demo of the new deployment option on the multi-AZ feature. We'll provide a comparison of the two various availability options on Amazon RDS. We will answer your questions and we'll close the call. So what is Amazon RDS multi-AZ? Amazon RDS multi-AZ is a feature of Amazon RDS that provides customers with highly scalable, available, and durable databases. In this deployment option, Amazon RDS creates a primary instance and a secondary instance in two different availability zones and synchronously replicates the data between the two. When there is a failure of the primary, Amazon RDS automatically fails over to the secondary instance without any manual intervention. This multi-AZ feature is available on Amazon RDS MySQL, MariaDB, PostgreSQL, SQL Server, and Oracle databases. To help customers further customize their Amazon RDS to suit their application and workload needs, we now offer two different deployment options. The first one is Amazon RDS multi-AZ with single standby. And the second one is the new deployment option that we announced on March 2nd. It is the multi-AZ with two readable standby database instances, or multi-AZ DB cluster in short. Let's talk about each one of them. Let's start with multi-AZ with a single standby. In this deployment option, Amazon RDS creates a primary instance and a secondary instance in two different availability zones. It then sets up synchronous replication between the two. The secondary instance is there simply waiting as a failover target and is not accessible by the applications. It is waiting to spring into action whenever there is a failure of the primary. Let's look under the hood on how this works. The write or the commit path ensures that the data is in two different places. So when there is a write on the primary, the data is first written to the EBS volume of the primary. It is then sent to the secondary, where it's written on the EBS volume of the secondary. Then the secondary sends an acknowledgement to the primary, and the primary sends an acknowledgement back to the database instance. At this point, the data is in two different places, and the transaction gets committed. The write latency here is the cumulative latency of the time it takes to write on both the EBS volumes, plus the acknowledgement time from the secondary to the primary and the primary back to the database instance. Now let's take a look at what happens when there is a failure. The failure can happen either on the primary or the secondary. When there is a failure of the secondary, the application continues to talk to the primary. Amazon RDS detects the failure and then goes and replaces the secondary and then reestablishes the replication between the primary and the secondary. Now let's talk about when there is a failure of the primary. When there is a failure of the primary, it's a little bit more elaborate. So when there is a failure, RDS detects that failure and then stops the replication between the primary and the secondary. It then promotes the secondary to be the new primary. The application reestablishes the connection as it's continuing to talk to the same endpoint, and now it can start. It starts talking to the new primary. Amazon RDS goes and replaces the secondary and re-establishes the replication between the primary and the secondary. Now let's talk about our new deployment option, which is multi-AZ with 2 readable standbys, or the multi-AZ database cluster. This new deployment option is available today in Amazon RDS for MySQL, as well as Amazon RDS for PostgreSQL databases. In case of MySQL, it's available on the version 8.028, and for PostgreSQL, it's available on version 13.4. This deployment option offers 4 distinct benefits. It provides faster transaction commit latencies, or in short, improves the transaction performance. The failover times are typically under 35 seconds. With 2 readable standby instances, it offers additional read capacity. It further helps maximize performance by splitting the reads and write workloads. Let's first take a look under the hood on how this works and then get into detail about these benefits. This deployment option makes use of a new type of instance with a local storage volume. So those are M6 GDs and R6 GDs. So when there is a write to the primary, Amazon RDS first writes the log files, the vol file or the bin log file in case of MySQL, to the SSD of the primary. Then these log files are sent to both the standby instances. And as soon as it gets an acknowledgement from either one of the standby instances, the transaction is committed. As you can see here, the transaction commit path happens within the SSDs of the primary and the standby instances, and it does not involve the EBS volumes. The data is then later flushed asynchronously to the EBS volumes for durability. When there is a read, the data is served either from memory or from the EBS volume, depending on where it is residing at that particular point. So this architecture provides or helps with the benefits that we discussed earlier, and let's get into the details. So this is the performance chart that shows the comparison between the multi-AZ feature with a single standby and 2 readable standby instances. This performance chart, we used MySQL Sysbench Workbench, and I'm going to put a caveat out here that it is a synthetic workbench, and you get out of it what you put into it. But in this case, it's driving the database really, really hard. And as you can see from the chart here, as the number of threads go up, you can see the TPS increases by 1.7 to 2.3x in case of multi-AZ with 2 standby instances. And we also observed reduced latency by about 2 times. let's talk about what happens in case of a failover. In case of failover with a single standby instance, Amazon RDS starts two different processes. It starts a crash recovery process as well as a DNS propagation process. And both these processes need to complete before the failover is completed. So this typically takes about 1 to 2 minutes. In the case of the new deployment option, there is no crash recovery step. So the failover time typically is under 35 seconds, as it involves just the replica lag, which is the time that is needed to commit the transactions that are in flight from the primary to the secondary, and just to promote one of the secondaries to be the primary. As a result, you see the failover times are much faster in case of this new deployment option. In this deployment option, we provide two different cluster endpoints. So we have a write endpoint as well as a reader endpoint. The writer endpoint is connected to the primary database instances, and the two readable standby instances are load balanced and connected to the reader endpoint. When the primary fails, one of the readable standby instances will be promoted as the new primary, and they will still be connected to the same cluster endpoints. So the applications that are reading from the reader endpoints or which are connected to the writer endpoint, they will be continued to serve by one of the instances that we keep moving around as they fail or fail over. So this is the advantage of using the cluster level endpoints as we manage the failure of the instances in the backend. In some cases, some of our customers have the failover logic in their application itself, and they want to connect to these instances directly. In such cases, we also expose the instance endpoints. So we have 3 instant level endpoints and 2 cluster level endpoints. So in some, we expose 5 different endpoints. In the case of this deployment option, it's also important to understand the replica lag concept. Replica lag is the difference in time between the latest transaction on the primary and the time it takes to get committed on the secondary or the standby instances. The standby instance, as we saw in the earlier slide, they are serving the read workloads, but in the backend, they are also applying all the transactions from the write instance. So this can cause replica lag under certain situations. So for example, when there is a high volume of concurrent write workloads on the primary, while the read instance is serving a huge volume of read workloads, that could be a replica lag, as the reader instances are quite busy serving the read workloads. In other cases, when there is a large amount of DDL statement, it can cause replica lag as well. So in order to mitigate the replica lag, we can either reduce the load on the writer DB instance or try to avoid long-running transactions such as the DDL statements in the primary. We also provide a flow control mechanism to help mitigate the replica lag that can provide the tolerable limits for the applications. So this flow control mechanism is exposed as a parameter in case of MySQL, and it can be deployed as an extension in case of PostgreSQL. And the default value of the parameter is 120 seconds. Basically, the replica lag parameter helps determine the maximum lag that we want to allow between the transaction on the primary and the time it takes to get committed on the secondary. Once a replica lag approaches the limit, this mechanism will start slowing down the writes and allow the secondary instances to catch up to the primary. If you want to disable flow control, this parameter can be set to a maximum value of 1 day or 86,400 seconds in case of MySQL. And in the case of PostgreSQL, you turn it off by simply removing the extension and rebooting the database instance. At this point, I would like to turn it over to Vijay for taking you through a demo of this new deployment option and also going through the rest of the slides.
Thank you, Prasad. That was a great overview on multi-AZ DB clusters. Now, as part of this demo, we're going to see how can we create the multi-AZ DB clusters with 2 readable standbys. And then I'm going to walk you through the failover process. And we're going to end the demo with distributing the load between both the reader instances with the reader endpoint. So let's get started. From the RDS console, click on Create Database. As you already know, you can create multi-AZ DB clusters only with MySQL version 8028 and Postgres versions 13.4. For this demo, I'm going to choose MySQL and select the version. Under the availability and durability section, now you will see the new option, which is multi-AZ DB cluster. This provides us 1 primary instance with 2 readable instances. Rest of the configurations are pretty similar to creating any normal RDS instance. So I'm going to leave them as default and then create database. In the interest of time, I have already created the multi-AZ DB cluster. So let me get back to that. So let me cancel here. As you see here on the screen, I have my multi-AZ cluster with 1 writer instance, which is in availability zone 1A, 2 readable reader instances. They are in availability zone 1B and availability zone 1C. Under the connectivity and security, as you see, there are 2 endpoints. We have a reader endpoint and a writer endpoint. The reader endpoint always points to the 2 reader instances and it distributes the load between both the reader instances. And the writer endpoint always points to the writer instance and you can do read-write operations using this writer instance. Now that we have seen the cluster topology, now let's do a failover between writer and then reader instance and see how that looks like. For that, I'm going to go to the terminal. So what we have here is multiple microservices for our Recal website, and these services are containerized and we use Docker Compose to manage those microservices. So let me quickly show you how the configuration looks like. As you see here, we have multiple microservices, web app and products and user microservice and then order microservice. These microservices are using our multi-AZ cluster endpoints. This is the writer endpoint cluster and this is the writer and this is the reader endpoint cluster, and they have username and password to connect to the database. Now what I'm going to do is I'm going to bring up the application. So for that, I'm going to bring up the Docker Compose up, and which is going to start the microservices. Looks like microservices are up and running. So our application should be up and running. So what I'm going to do is I'm going to open a Cognito window and then let's open the application. So behind the scenes, this application is using those microservices. And these microservices are connected to our multi-AZ cluster. Now what I'm going to do is on this window, I'm going to generate some load. So for that, what I have here is I have create order.python. So let me run that. So I'm going to run that create orders.python, which is basically behind the scenes going to generate a lot of orders to our application. So while that is happening, I want to show you what's really happening on the database side. So here in the terminal window, I'm going to connect to the RDS multi-AZ cluster, and then going to query that order table that we are generating orders to. So we have right now 515 orders. So I'm going to count again to see. So 521. So which confirms our orders are getting generated. Now what we're going to do, let's do a failover and see how our application behaves. So for that, I'm at the RDS console, and then from the actions, I'm going to click on failover and then confirm the failover. Yeah, our failover is started here. So let's go back and see from here. Our order creation is failed, failover is started. And then my script is trying to connect to the database again. And you see from the application side, we are seeing some errors. So let's see how long it normally takes. And there you go, successfully creating the orders. And let me stop the script here. As you see here, our failover started at 6:59:00 seconds and ended at 6:59:24 seconds. So total, it took 24 seconds to do the failover. So this is the another advantage of the multi-ACDB clusters, right? Because you have a standby read replica instances, they're up and running. So normally the failover would take much quicker. Um, and sometimes failover may take longer because depends on the amount of writes we are doing on the primary as well. If there is a huge replication lag, sometimes failover times depends on the replication lag as well. Typically, the failovers should happen under 35 seconds. Now let's do the third part of the demo, reader endpoint distribution. For that, what I'm going to do is I'm going to refresh here. So what I have here is load multi-AZ reader endpoint Python script. So I'm going to use that script to distribute the load between the reader endpoints. Let me run this script now. As you see, the script is taking multi-AZ reader endpoint as parameter and username and password and amount of time that is going to run. So let me start this. While this script is running, let's go back to our RDS console. As you see here, our instance 2 and instance 3 are the reader instances, and the load between both of them are getting distributed in a round robin fashion, and the CPU usage is also going up on both of them. So this demonstrates the multi-AZ cluster reader endpoint, which distributes the load between both the reader instances. With that, our demo is concluded. Now let's get back to the presentation.
Now I will be talking about some options that are available for Amazon RDS multi-AZ clusters. RDS multi-AZ clusters only available with Graviton 2 instances. So the benefit is which offers up to 35% performance improvements. The M6GD is a general purpose instances. It has 8 gigs for every 2 cores, and it is good for running CPU intensive workloads. Then R6GD is a memory optimized instances, which has 16 gigs for every 2 cores with high performance networking and good for query intensive workloads or high connection concurrent connections. Both these instance types are supported by NVMe SSD instance store. The storage volume supported for multi-AZ DB clusters is provisioned IOPS, IO1. So this is SSD storage that lets you provision IOPS independently so that you can tune your application to what you need. There will be additional storage volumes available in future. This provision IOPS provides single-digit millisecond latencies, better performance, and it will provide maximum up to 80,000 provision IOPS. Now I will show you how you can get started with RDS multi-AZ with 2 readable standbys. First, we will talk about how you can create multi-AZ DB clusters. Before I go there, I want to call out, you can create multi-AZ DB clusters in AWS regions, US East, Ohio, and Northern Virginia, US West, Oregon, Europe, Ireland, and Asia Pacific, Tokyo. As you see on the screen, above are the API calls for multi-AZ DB instance and multi-AZ DB clusters. The multi-AZ with one standby, the API call is AWS RDS create DB instance, and for multi-AZ with 2 standbys is AWS RDS create DB cluster. So for the top level object, a DB instance has 1 standby and DB cluster has 2 readable standbys in an multi-AZ deployment option. Otherwise, the API call looks the same. You choose a name, an instance, and an engine, a version, etc. And as you see, it has provisioned IOPS configured with 10,000 IOPS. Now, how you get your existing databases into the multi-AZ clusters? You can create a net new multi-AZ cluster, but if you want to migrate existing data, there are 2 key approaches. The first is to do a snapshot restore. In this case, you create a DB snapshot from your existing single AZ or multi-AZ instance, then do a restore DB cluster from snapshot API call, as you see on the screen, using the same snapshot. And you will deploy the new instance. You will note that you have to make change and declare what instance type you want, but otherwise it is a snapshot restore. The second option for migration is to use for high availability migration, is to use using our AWS database migration service. As you see on the screen, you can have your application connected to your multi-AZ DB instance and configure database migration service to do the migration for you to a new multi-AZ DB cluster instance. Attached in the slide, a blog that goes into more details on this process. Now I'm going to talk about RDS availability options. Now we will dive into how these different options compare across specific capabilities. First, we will look at additional read capacity across single AZ, multi-AZ with 1 standby and multi-AZ with 2 readable standbys. For single AZ, your read capacity is limited to the capacity of your primary instance. For multi-AZ with 1 standby, you get no additional read capacity as your standby DB instance is only a passive failover target for your high availability. But for multi-AZ with 2 standbys, your 2 standby database instances act as failover targets and also serve read traffic. Read capacity is determined by the overhead of write transactions on your primary instance. For lower latency, higher throughput for transaction commits, single AZ is not applicable as your writes are not being committed to standby instance for high availability and data durability. For multi-AZ with one standby instance, you will have some write latency as multi-AZ will synchronously replicate your data to a standby instance in another availability zone, as we outlined earlier. With multi-AZ with two readable standbys, the time for your transaction to be committed is 2 times faster than with multi-AZ with one standby. For automatic failover on single AZ, this does not exist. When a failover occurs, Amazon RDS will attempt to restart the primary, and if it is unavailable, will attempt to replace it. However, during this time, your application is unable to connect to a database as there is nowhere for it to fail over to. Instead, you must perform a user-initiated action like point-in-time restore operation, which can take several hours to complete. Another, any data updates that occurs after the latest restorable time, typically within the last 5 minutes, will not be available. For multi-AZ with one standby, Amazon RDS can failover your database as quickly as 60 to 120 seconds, and failover time is independent of write throughput. For Amazon RDS multi-AZ with two standby failovers, typically takes less than 35 seconds, and failover time depends on the length of the replication lag that we already discussed in our demo. Nice. Next, let's discuss about the resiliency to AZ outages. With single AZ, there is no resiliency in case of an AZ outage. If this occurs, you risk data loss and hours of failover time. In multi-AZ with one standby deployment, in the event of AZ failure, your workload will automatically fail over to the up-to-date standby. In multi-AZ with two standby option, two standby database instances act as failover targets and serve read traffic for you. For lower jitter for your transaction commits, single AZ has no optimization for jitters. For multi-AZ with one standby, your application is sensitive to any imperatives on the write path. For multi-AZ with two readable standbys, it uses 2 out of 3 quorum. Therefore, it is insensitive up to one impaired write path. Now I will hand over to Prasad to conclude this presentation.
Thanks, Vijay. So, in conclusion, Amazon RDS multi-AZ with two readable standby instances is available on MySQL 8028 version and PostgreSQL 13.4 version. And it offers 4 distinct benefits. The first one is faster transaction commit latencies by about 2x times. The failover times are typically under 35 seconds. It provides increased read capacity with 2 additional read replicas. And it also maximizes performance by splitting the read and write. In case you are interested in knowing more, here are some helpful links. With that, I would like to conclude the presentation and open it up for questions.